Okay, you're going to go ahead and complete the warm-up. The graph that the warm-up is talking about is this one right here. So the first question says, the graph represents the amount of time it takes a ship to travel various distances in miles. How many miles did the ship travel in 6 hours? So use your axes to help you find that 6 hours and to get the second part of your data. Our next question says, Mr. Escobar bought his son Mateo a bag of lollipops. The bag contained 40 lollipops and 8 of them were cherry flavored. What percent of the lollipops were cherry flavored? So circle your keywords, underline what's important. And we see that this question is talking about percents. So you know you're going to have to use a percent proportion. Today we're going to keep on talking about proportional relationships. Our SE, I can represent constant rate of change in mathematical and real-world problems given a pictorial, tabular, verbal, numeric, graphical, and algebraic representation, including D equals RT. Our language objective, I can write to explain how to find the constant of proportionality from a table. So we're going to go ahead and fill out our notes here. It says a proportional relationship is written as a straight line. Label the independent and dependent variables. So y is our dependent, x is our independent. K represents the constant of proportionality. So for this, we use a triangle. We're going to separate it. We have y, we have x, and we have k. So each of these is going to help us solve. We know that y over x, when we divide, that gives us our k. We're just giving the answer a name. The next one, you can also think of finding the constant of proportionality as finding the unit rate. So here we have a statement. It says a black bear travels at 12 miles per hour. Complete the table based on this relationship. So if they travel 12 miles in 1 hour, we can just multiply that number by 12. In 2 hours, it's going to travel 24. In 4 hours, it's going to travel 48. In 8 hours, it travels 96. We're just multiplying the x by our constant right here, which is 12, to find y. To find the constant of proportionality, you divide the y by the x. This relationship in the table is proportional because it stays the same. So every time you go up 1 on x, it's going to go up 12 on y. On a graph, a proportional relationship must start at the origin and must form a straight line. So when we have a graph, it needs to start right here, and it can go up or down, but it needs to be a straight line. Example 1, which table shows the constant rate of change of 325? So this is just like what we did with the bear. We have money is always going to be my y. So the cost is my y. So my other one has to be my x. So I multiply the x by this number right here. So 1 times 325. That's correct. But that's also correct for all of the tables. So we try the next number, 325 times 3. You're going to multiply, and you'll notice that some of these are different. Whatever you get is going to be correct. If that number is incorrect when you multiply, then you're going to cross that out. So 5 times 3 is 15. 3 times 2 is 6, plus 1 is 7. 3 times 3 is 9. Write a decimal, so 975. I can cross out F and I can cross off G. My next number, because these two were correct, is times 5. 325 times 5. 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. 5 times 3 is 15, plus 1, 16. Move the decimal 2 times. This one is wrong. This one is right, so I can cross off. I'm left with H. So again, you're just multiplying the x's by your rate of change. We do the same thing for this one. It says, look at the table. What is the constant rate of change for this relationship shown in the table? So, K equals Y over X.
Teachers, please allow students into your classroom at this time.
3. Your turn.